कई बहुत मारेगा कई मारेगा करना बात को
Assalamu alaikum. Today we are going to learn about the bases. We have some prior knowledge about the bases. What are they? You can say some examples for bases. What are they? The best example is soap, toothpaste, shampoo, lime water, baking soda, milk of magnesium. These are, we are very familiar substances. They are bases. Can you identify the bases by touching? What do you feel when you're touching the soap and toothpaste or shampoo? Is there a common physical property among these substances? Yeah, that is slimy texture. So, this slimy texture is a physical property of base. But always we cannot touch and identify the chemicals. They are dangerous. So, we know identify the bases using some indicators. From grade 7 to we have been studying about it. What are they? Very easy. The litmus paper. Always the litmus paper show the blue color in base. Litmus, blue color in base. You can remember that blue B. That is my way. I remember that like this. Blue color base. B, B. So always the litmus show the blue color in bases. Very easily we can keep it in the mind. And we know phenolphthalein. We have experience about the phenolphthalein. The phenolphthalein is showing the pink color in only base. So phenolphthalein is an indicator, can be used to identify only the base. That is also special. So blue color and phenolphthalein is special. But when we categorize the bases according to weak base or strong base, this phenolphthalein and litmus is not there. There we have to use the range, color range according to the strength, that is pH scale. In the pH scale, 7 to here, litmus. Blue. Phenolphthalein. These are, this blue and phenolphthalein are special for identify the base. But according to the strength, we can use the pH scale. pH scale. In the pH scale, greater than 7 are base. What is the range of pH scale? 1 to 40. 7 is neutral. So, greater than 7 is what? This is less than 7, isn't it? So, bases are greater than 7. Then that is 8, 9, 10, 11, 12, 13, 14. That's a range. Okay. These are our previous knowledge. If you want to study more about the bases, you have to understand the formulas. Okay, let's write the formulas and try to understand how the chemical properties of these bases. Okay. Sodium hydroxide. Potassium hydroxide. Magnesium hydroxide. Hydroxide. NH4 OH. Just we can write it. NH4 OH. Okay. Now, if you carefully observe these formulas, what is the common component? This OH. Is common for all the bases. Then, what is a base? Base is a compound. This is a compound. You know, this is sodium, oxygen, hydrogen. There are 3 elements. It is a compound. Base is a compound that ionize in the aqueous medium and releases this hydroxyl ion. Okay, let's see how this ionize. You know, already you have learned this arrowhead is complete ionization, isn't it? So, here sodium cation and hydroxyl anion. This is an ionic compound. So, let's separate this. It should be in aqueous medium. This sodium chloride we can get as solids. As fluids in the laboratory we can take it. Sodium hydroxide powder also in the laboratory. When we add that into the water, that is aqueous medium. So, in the aqueous medium, it ionizes sodium plus aqueous medium. Sodium and OH minus. Completely separate. If there is 1 mole sodium hydroxide, there will be 1 mole sodium cation. 1 mole hydroxide. So, it is completely ionized. This KOH also like the same. It ionizes completely. But this magnesium hydroxide not completely ionized, partially ionized. So you need not the equation according to the ordinary level. You have not given to understand furthermore, but for a knowledge, you understand how this molecule ionizes. How? Magnesium 2 plus and OH minus. But the whole magnesium hydroxide is not ionized, partially. It means in that solution there are magnesium hydroxide, means undissociated magnesium hydroxide and dissociated magnesium and hydroxide, hydroxyl ion. 1, 2, 3. 3 types of molecules are available in the solution. Okay, but here, there, if we dissolve the sodium hydroxide into water, there will be sodium hydroxyl ion and the H plus ions like that. No sodium hydroxide molecules. Completely it dissociates in the water. But here there will be undissociated magnesium hydroxide molecules too. Okay, now I think you have understood how this complete ionization and the partial ionization taking place in the bases. So according to this, if you start to write this one, ammonium hydroxide, that one also partially ionized. Very quickly I want to complete this, and so I am not writing the ionization formulas here. So according to the strength of ionizing, these bases can be categorized into two: strong base and weak base. Okay, using this pH scale, we can identify the weak base and the strong bases. If it is strong base, it shows the number 14, that is dark blue. Sodium hydroxide, so the dark blue, the last color, the last, the end range, the top level, 14. KOH also like that. But this MgOH twice, NH4OH, 10, 9, 8, within this range, it shows. Whatever you have a substance, if you want to check that whether it's a strong base or a weak base, you can use this pH range. If it is between 8 to 14, you can measure the strength of that. Okay. Now, let's see how these bases are chemically react. Excuse me. You need not to write the notes because this class is on the being recording, so you can repeat this. Okay, then I'll erase this. Okay, now let's see the chemical property. We know acid is a special character, but base is not a special character, but both are completely opposite enemies. But when these two enemies are together, their peace prevail. What's that? Salt and water, neutral and cool. Salt is neutral, water cool. Sweet. Okay. Then what am I going to say? The same reaction. Yesterday also I talked about that. That is, the base is going to react with the enemy. Acid is going to react with enemy. What is that? Acid base reaction. So when base react with acid, when acid react with base, both are same. How? Let's write an example. Already we have done, but here again I remind that. Okay, the very familiar sodium hydroxide. Here I am going to write the base first because we are learning about the base now today. Yesterday when I was teaching about the acid, I write the acid first, but both are same. Sodium hydroxide and hydrochloric acid. this positive and this negative. Then sodium chloride, neutral, salt, common salt. And this OH and this H, that is water. So when bases react with acid, it forms salt and water. Okay, it's enough. Now I am going to talk about the salt. Okay, how do these salt form? The cation in the base, anion in the acid. Cation from the base, anion from the acid makes a salt. This positive and this negative. This is positive and negative. So this is which type of compound? Covalent to ionic compound. Definitely that is an ionic compound. That's why the melting point of the salts is high. Ionic compound. They are in crystal form, because that is ionic compound. Molten salts conduct electricity. Why? There are positive and negative ions. Aqueous solution of these salts conduct electricity. Why? There are mobile ions. So, all these things we have already known. But, especially we are talking this again. We are specially mentioning here about the salt. So, what is called this reaction? Base and acid, or acid and base. This reaction is specially named acid-base neutralization. So what is acid-base neutralization, or what is neutralization? It becomes neutral. Isn't it? So proud. Huh? Proud of the product acid. When both react, become neutral. Slow down. The type of acid also is a type of temper, but after reacting become cool, neutral. Acid-base neutralization is reacting an acid and a base and produce a salt and water. Salt and water. Then once again repeat what is neutralization. Reacting acid and base forms a salt and water. Then what happened there? The acidic nature and the basic nature disappear. Isn't it? It become neutral. So neutralization disappear the acidic nature and basic nature. Isn't it? Okay, it's enough. Now we have learned about the physical property of base, how to identify the base, and the chemical reaction of base, and the neutralization, and the salt. Okay. These salts can be categorized according to the reacting base and acid as neutral, basic, or acid. Sometimes some salts display little amount base property in the aqueous solution. Otherwise, acid property in the aqueous solution. Why? That is depending on the reacting base or acid. Okay, let's see that. Base property and the acidic property of salt. Okay, excuse me. Now, let's consider what is this base. Is it strong or weak? That is strong base. Now, we are taking this acid is strong or weak? That is strong. So, strong and strong. Produce completely neutral. Salt. Now, we consider strong base a weak acid acetic acid like. It forms sodium acetates. Sodium carbolic acid, H2CO3, carbonic acid. what will be the product? Sodium HCO3 minus. Then Na, this is 2CO3. And this water is a common product, isn't it? Here also water forms. Water is common for all the neutralization. Here, base is strong. Acid is weak. Now, what is the product? Sodium carbonate. This is, it shows the base property. So, this salt shows the base property. Why? In the neutralization, the base was the strong, acid was the weak. Now, like this. Now we are going to take a weak base. Weak base, magnesium hydroxide, and strong acid, HCl. What will be the product? Magnesium chloride. It is like this, isn't it? But here the acid is strong. So this shows acidic property. Okay, that's all. Okay, now let's see the uses of bases. The common base, we know sodium hydroxide. What are the uses? Always we are using the soap. So, to produce the soap, the sodium hydroxide is a raw material. So, in the page 195, you have given uses of some bases: sodium hydroxide, production of soap, paper, artificial silk, and paints. Use in the laboratory as a strong base. Yes, we are using that. Refining petroleum products. To purify the petroleum product also, this sodium hydroxide is used. Okay, go to the next. Magnesium hydroxide. Always we are talking about the magnesium hydroxide, that is milk of magnesium. That is used as an antacid. So, if we have gastritis problem, there are HCl excess in the stomach, that is the problem. So, to neutralize that, here HCl. Yeah, this is the same formula we have written here. That's nice, isn't it? What is happening inside the stomach? If we take the magnesium hydroxide, neutralize. Relieve from the stomach ache. Here, cool down, isn't it? No basic property, no acidic property. Disappear, cool down, neutral. So, this is the case occurring inside the stomach for the gastritis people. So, take magnesium hydroxide if you have gastritis. According to the scientific reason, you can explore. Isn't it? Okay, this is the case that given here. Then, The next one is purification of molasses in the sugar industry. Sugar industry, you know, they are taking the sugar juice and making crystals. Isn't it? In the sugar industry, when they are taking the juice, there are dirts. To remove that, this magnesium hydroxide is used. That's all. Now, the indicators, I have already explained about the indicators. You know, the litmus always show red in the acid, blue in the base. That's all. The next phenolphthalein show pink only base. Orange, methyl orange, red in acid. Okay, I will erase this and explain. Excuse me. Now, let's talk about the indicators. Okay. Indicators. What are the indicators we know? Litmus, phenolphthalein, methyl orange, and it will be fight off with your pH scale. pH. Okay. Acid. Base. Always the acid, so red side. The base, blue. Blue and red are the two main colors in indicating the acid or base. So, very easy to remember, blue is base. Blue side is base, except phenolphthalein. So, the phenolphthalein is special. But that special is for base. See it? Base always blue, but with the special friend phenolphthalein, with phenolphthalein that is pink. You remember this diagram. Pink, phenolphthalein is P, pink only base. No color change, colorless. Colorless in the acid. So, I am not writing anything here. Colorless. Great. But litmus always red. always blue. Methyl orange, here red. Red, red, red. pH range, dark red. That is number 1. 1, 2, 3, 4, 5, 6. This one is dark red. Red to yellow, it decreases the color. But top color is red. If it is strong acid, that is number 1. Red. Red to the decreasing color, it's like yellow, like that. Okay. Then this one, this side will be here red, methyl orange. Orange is the top side is, orange is mix of red and blue. Isn't it? Orange is mixture of red and yellow. Okay. So, methyl orange is in the middle. If go to the acid side, red. Acid is always red side. Okay. The opposite side is base. Red and yellow. So the yellow. Isn't it? That's all. You know this range. What is that range? 8, 9, 10, 11, 12, 13 and 14. That's all. The ranges. Okay. Now, again and again they have explained about the salts. I have already explained that. About the salt. It's enough. Now, let's see about the uses of some salts. Okay. Excuse me. Okay. Sodium chloride is given. Again, we have discussed about the sodium chloride. NaCl. Now tell, how do this sodium chloride form? Sodium hydroxide. So, in the salt, the cation part is from the base, anion from the acid, anion from the acid, cation from the base, isn't it? So, this is from the hydrochloric acid. This is from the sodium hydroxide, isn't it? So, this sodium chloride is used for what? That is common salt to prepare food, isn't it? The first use that given. Used for food preservatives. Yeah. when making pickles. Pudesika, uppu manga. Uppu. What is that? Salt fish. I don't know, that much only I know. So foods can be preserved using the salt. Okay. Then to produce chemicals such as chlorine. To explain that only I put this formula. Chlorine. How to produce the chlorine? Yeah, we have learned in grade 9 these two particles. Sodium ion and the chlorine ion can be separated. How? Yeah, using the molten sodium chloride in the liquid state. When electrolyzing, we can separate sodium and chlorine. If we use sodium chloride aqueous solution, it gives what? Sodium hydroxide and chlorine. So we can produce chlorine. We can separate sodium metal. We can produce sodium hydroxide using the salt water. Aqueous sodium chloride, electrolyting, taking this, remains, taking chlorine. Okay. So to produce chlorine, this salt is used. Okay. Next, to produce chlorine, chemicals are chlorine and hydrochloric acid. If we got this chlorine and H2, Cl2 and H2 reacting, it produce HCl, isn't it? So, to produce HCl, so we can get the sodium metal. It is not mentioned here, but we can get the sodium metal by separating this, and chlorine. By this chlorine we can get the hydrochloric acid. So this is mentioned here. Sodium carbonate. If we have sodium, we can make several reactions and we can take several products. If we have this sodium hydroxide here, if we subject it to if this sodium hydroxide undergo other chemical reactions, we can produce sodium carbonate, sodium bicarbonate, that is our baking powder. Like many different products we can produce using this sodium powder. So this is the raw material. Using that, we can produce so and so products. Using this we can produce soap, isn't it? And also used in tanning. What is tanning? Tanning means making use of the skin, not human skin, but cow, goat, like these animals. Using these animal skins, they preserve that using the sodium chloride. If you ask this with the butcher shop or butcher man, secretly, they will explain, and you can see if you go to that side, there I have seen they are taking that skin as a bag, and they fill the skin with the sodium chloride salt. Then the bad smelling not coming. It is not spoiled. They preserve and use, and they give that to some other factories. They sell that, and in the factories they are using the tannin. So I have a little experience in my childhood. Now only I realize that's why the sodium chloride is used in tanning. Okay, தோல் பதனிடுன்னு சொல்லி அதை தமிழில் செல்ற தமிழ் புக்கில் வந்து தோல் பதனிடல்னு போட்டிருந்து அதை வச்சுதான் நான் யோசிச்சுக்கொண்டு நான் கண்ணால் ஒரு கண்டிக்கிறேன். அப்படி ஆட்டுத்தோல் மாட்டுத்தோலுக்குள்ள உப்பு போட்டு பேக் மாதிரி கட்டி அனுப்புறத்தில் ஒரிகளில் போட்டு இப்போதான் எனக்கு விளங்கின அந்த பதனிடுற அது இல்லாட்டி அந்த நாத்தம் வருமே உரிச்சதோல் அப்படி நாத்தம் இல்லாம அதை அப்படி செய்யறவங்க. அது தோல் பதனிடுறதுக்கு இந்த சோடியம் குளோரைட் சால்ட்டை யூஸ் பண்றேன். ரைட், அவ்வளோதான் காப்பர் சல்ஃபேட். எங்களுக்கு தெரியுமே, உங்களுக்கு தெரியும். நாங்கள் பேடிக் சொல்யூஷன் எடுக்கிறதானே. என்ன கலர் அது? That is in blue color. Basic solution, blue color. You have seen that in the laboratory. So, basic solution and filling solution, both are blue. So, to make these solutions for the laboratory practicals, copper sulfate is used. Neat. Okay. And used as a fungicide in agriculture. Okay, now I am talking about the copper sulfate. So I want to trace this. Excuse me. Now we are talking about copper sulfate. Copper sulfate. In this copper, there is sulfur. We have learned about the sulfur. Sulfur is used as a medicine for, is it used as a fungicide? Isn't it? So, there is sulfur. It is used as a fungicide. Okay, in agriculture. So, in the fields or gardens, they use this. Okay. And used electroplating. Again electrolyzing. Again and again electroplating. Electrolyzing. Okay. We have learned that. So we know in the electroplating it is copper sulfate aqueous. Aqueous copper sulfate. We have done this. Isn't it? We have done. It separates electrolytes. When electrolyzing, copper deposits. Isn't it? So, copper is used to electroplating. and used in paint industry. Okay, in the paint industry. So these are the uses of copper sulfate. That's all. Now neutralization already we have done. What is neutralization? Here they have given the neutralization definition. Neutralization is the combination of H plus ion released by the acid with OH minus ion released by the base to form both the molecule. So you know the neutralization also. Now let's see the applications of acid-base neutralization. Already I have explained, isn't it? So what is the application? Milk of magnesia again. I said I am not repeating that. The second one, base substance such as quicklime. Now you don't know about the ash because everywhere, every home using the gas, but somewhere on there is ash and firewood, isn't it? But you know, however, that what is ash? Ash is a base substance found at home, or in the fields also. They are burning the garbages and burning firewood. They are and however, they are getting ash in the channels or fields, and they are adding that to the soil to neutralize what? The acidic nature of the soil. Okay, and calcium carbonate. Hunu under silver. Sunnambu, calcium oxide. இதுகளையும் போட்டு they neutralize the fields and the channels or the gardens when cultivating plant. To neutralize the soil, these substances are used. That is application of base acid or acid-base neutralization. Okay, special bee sting. Painful because of acidic poisonous. The poison sometimes acid, sometimes base. Okay, bee sting is acid. So how to neutralize that? We can neutralize by washing soap. I have experience. Red ants, small ants, I have bitten by red ants. My mama told to wash using the soap. It will relieve. I did. So I got rid of that pain. Sometimes some types of mosquito biting, it's very itching. Then when washing using the soap, it will be okay. So what is the reason scientifically? Some poisons are acid. So when applying bases, it will be neutralized. And the last one, wasp. Wasp means what? Kolavi. Kolavi, debaran அது மாதிரி. சரியா தெரியா? Kolavi, debaran ரெண்டுல ஒன்றுதான். That is basic. Basic. So we can apply lime juice or vinegar. But you should not confuse that. Some insects poisons are acid. Without knowing if you apply for the acid poison, acid, lime juice or any vinegar will be serious. So don't use this without any experience or without any advice. That is just don't get this as a practice. But was using the soap if anything bite you. Okay, that's all. Then let's go to the exercise, that is page 200. Quickly we'll revise that. Okay, complete the following sentences. You try. Sodium hydroxide and acid react form sodium chloride and water. Here given what? Sodium hydroxide. Sodium hydroxide and dash forms what? Sodium chloride and water. Okay. Here sodium from this base, chlorine from this water is this OH, and here is an H plus. It become water. Isn't it? H plus and OH minus brought the water. Then how do this chlorine get? It is from this HCl, isn't it? That is the way finding out the base or acid using the salt. You can identify which acid and which base react to produce this salt. You can do that. Okay. Next, calcium carbonate and hydrochloric acid. Calcium carbonate and hydrochloric acid. That is a carbonate and a hydrochloric acid react liberating. We know acid react with carbon and produce what? CO2. Liberating CO2. And we know the formula. Potassium hydroxide, third one, KOH, and sulfuric acid, H2SO4, react to form what? What is the salt produced here? K, this K, I use another color pen, that's better. Here, this K and this SO4. We know K plus SO4 2 minus. So, K2SO4. KOH H2SO4. The next part is, this is the salt. That is common for what? Neutralization. That is H2. This one and this one. Okay. Go to the next. Here, again my body is feeling, so excuse me. Okay. The fourth one, dash, and this is acid. So we have H plus. They have mentioned as acid, and dash hydroxide. So there is OH is what? Giving magnesium nitrate. So we have got the magnesium nitrate, MgNO3 twice. This is a neutralization. Here must be another product, that is water. Okay. Here acid and base. We want to find out the acid and base using the salt. Okay. So this magnesium is in this salt, this cation from the base. So this base is of magnesium. So that is magnesium hydroxide. This nitrate from the acid, HNO3. Okay. right, Asha. Okay, now the fifth one. Fifth one is, does acid, there must be H, react with magnesium, liberating a gas and forming the salt. Okay. Here is an acid. We know what type of reaction is this. They have mentioned there is an acid and a metal. Acids react with metals and liberate hydrogen gas. So it must be hydrogen. First gas is okay. Now a salt, isn't it? Acid react with magnesium, liberating hydrogen gas and forming the salt of what? Salt of what? Salt of what is the question? Salt of metal. So acid and metal react. Acid and metal react, forms salt of metal and liberate H2 gas. Am I correct? Acid react with the metal. Any metal? No. Metals above the hydrogen. In the activity series, already we have learned this. No need to repeat again and again. Acid react with metal and forms salt of the metal and liberate hydrogen gas. So, can you fill the gaps now? Yeah, acids react with magnesium, liberating hydrogen gas and forms salt of metal. Okay. Let's go to the second question. You are provided with 3 unlabeled solutions of sodium hydroxide. Excuse me. Fifth one again, acid should be dilute acid. Dil. What is dilute acid? We have learned about the concentration. The amount of moles of a substance dissolved in a unit of volume. That is, we have learned in unit 3 about the solution, standard solution we have learned. So, there, if the concentration is low, that is diluted acids. The reactions of diluted acid and concentrated acid, it is mentioned as dil and con. Dilute acids only reactant gives that reaction. Okay, but the reaction of concentrated acids are very different. It is used to dehydrate process. We have learned about the sulfuric acid, the dehydrating processing of sulfuric acid, isn't it? So that should be concentrated. So for this preparing hydrogen gases, we use this diluted acid only. So diluted acid and metal. You can mention the metal above hydrogen in the activity series. Use H2 and salt of metal. This is the correct way to answer the question number 5. Go to the 6. That's all, isn't it? Okay. Now go to the second one. You are provided with 3 unlabeled solutions of sodium hydroxide. This is number 2. Sodium hydroxide. Yeah. And dilute hydrochloric acid. Dil HCl. And sodium chloride. NaCl. That's all. 3 substances we have provided. Okay. How to identify these? So, you are given only blue litmus papers. Using only them, how you are given only blue litmus papers, using only them, how do you identify the above 3 solutions? Okay. Now you can answer the question. This is a base. It shows what color? Blue litmus, blue. Okay. This one, red. Shows the red color. NaCl, no change. That's all. You can answer that question. What the third one? Fill in the blanks with the solution selected from the following list of solutions. Okay, H2SO4, HCl, NH3, H2O liquid, calcium hydroxide equals CH3COOH, that is acetic acid. Okay, and turn red litmus blue. What turned red litmus blue? I think it's better if I clean the board, isn't it? Okay, wait a minute. Okay. Which turned red litmus blue? Blue is always, litmus blue is always base. What are the bases here? H2SO4 is an acid, HCl acid, NH3. NH3 is a gaseous base. See? But in the liquid state or in the aqueous, that is written as NH3 ammonia. Isn't it? Can be in the room temperature, it can be in the gaseous state. But it is, if it is in the aqueous solution, that is NH4OH. That is in aqueous solution. So this ammonia is what? NH4OH. That is a base. That is, so for the first one, answer ammonia, NH3 aqueous. So NH3 aqueous, it gives this, okay? NH3 aqueous can be written NH4OH, okay? Liquid H2O is neutral, no color change. Calcium hydroxide. Calcium hydroxide. These two are bases. For these are the answers. Okay, for the second one, this is for the answer for the first one. Now go to the second one. And act as strong acid. What are strong acid? H2SO4, H2SO4 and HCl. Answer for the second one. Go to the third one. In gas and pH is greater than 7. We know. What is the range for the base? Greater than 7 base. What are the bases? These two are. So that is NH3 aqueous, comma, CaOH twice. Go to the next, fourth one. Vinegar used at home is diluted. What? CH3COOH. CH3COOH. That is acetic acid. Vinegar causes severe burns in the skin when spilled. Which? This one. So this is the answer for the fifth one. Isn't it? Now for go to the sixth one. Calcium sulphate salt is formed by the reaction between and. Okay. Okay. Calcium sulphate. Here, this answer is for the sixth one. Yeah, I am writing for the answer for the sixth one. Can you see that? Okay. Calcium sulphate. CaSO4. This is from calcium from the base. This is that one. And sulphate from the acid. So this is that one. So this one and this one gives calcium sulphate. Am I okay? H2SO4, calcium hydroxide for calcium sulphate. Is it okay? An acid, base. Strong acid, weak base. So acidic property, salt. Go to the next. Fourth question. I think it's better if I clean the board. Okay, arrange the following solutions in the ascending order of pH. I think you can't stay more, so in this spot I will mark it. Sodium hydroxide, sulfuric acid, water, vinegar. Okay, so the higher range is base. Which is the base here? Sodium hydroxide, isn't it? Sodium hydroxide. Sulfuric acid is the lowest. H2SO4. That is lowest, strong acid. This is strong base. And water. Water is in the middle. But vinegar is left to the water, isn't it? Right side is base, left side is acid. So, this is the neutral. This is base, this is acid, this is neutral. Isn't it? So, the acid is this range. So, acetic acid is vinegar. So, vinegar should be get this position, that is CH3COOH, isn't it? Okay. Then what is the question? Arrange the following solution in the ascending order of pH. Ascending order means bottom to top or lowest to highest. So, what is the order? This is the order. Acid to base. You can arrange that. So, how to answer that? Question number 4. 1. H2SO4. Next to that, CH3COOH. Next to that, H2O. Next to that, NaOH. Am I okay? Okay. Now go to the second part. Of the solution, dilute hydrochloric acid, dilute sodium hydroxide and acetic acid, which does not react with sodium carbonate. Okay. Now, of the solution given here, isn't it? So, of the solution, dilute hydrochloric acid, dilute sodium hydroxide. Okay. And acetic acid, which does not react with the sodium carbonate. Sodium carbonate, Na2CO3. When learning about the reaction of acid with the carbonate, we written the example calcium carbonate. But here, we are going to react sodium carbonate. That is a kind of carbonate. So, carbonates react with what? Acid. Acid react with carbonates and forms carbon dioxide. So, what are the acids here? These two. Sulfuric acid and both can react with this carbonate because they are acids. Okay. Then which does not? What is the question? Question is does not. So, acetic acid which does not react with sodium carbonate. So, which does not react with sodium carbonate? Sodium hydroxide. Base. Base does not react with carbonate. Isn't it? Base does not react with carbonate. So, that is the answer. Okay, go to the next. When somebody come into the contact with the plant kahambiliya, இதுக்கு கசாம்பிலின்னு வீட்டில் சொல்லுவாங்க. வயசாளிகள்கிட்ட கேட்டால் தெரியும். இப்போ உங்களுக்கு காடுகளுக்கு போன அனுபவம் இல்லை. எங்கே சரி ஹைக்கிங் போனால் கசாம்பிலி எங்கன்னு சொல்லி யார் சரி சரி கேட்டு கசாம்பிலி கொஞ்சம் நீங்கள் எக்ஸ்பீரியன்ஸ் எடுங்க, பிடிச்சி பாருங்கள், மேலே கொஞ்சம் தொட்டி பாருங்கள், நல்லா இன்ட்ரெஸ்டாக. அதான் கஹம்பிலியா. So, when somebody come into contact with the plant kahambiliya, it causes itching. கடுக்குற, கடுமையான சொரிச்சல் அல்லது கடுக்குறன்னு சொல்றது. கொச்சிக்கப்பட்டதை விட கஷ்டமா இருக்கும். And severe burning, காந்தி சூடாகி சொகத்து போறண்டு. And burning sensation due to the formic acid. Reason? Formic acid. It contains suggests a suitable substance to apply on the skin to relieve that sensation. So, what is the position? What is the LH here? It is a acid. So, lime water or lime juice. If you apply lime juice, it will be very serious. Careful. So, you have to apply soap, baking powder, or lime water, or a toothpaste. So, okay. Magnesium hydroxide, milk of magnesia. Okay. At once, you have, if nothing, in the jungle, what can you do? No soap, no milk of magnesia. You have inside your mouth, what's there? Thylline, isn't it? The enzyme is what? Inside the mouth, what is that? Saliva, isn't it? Saliva also base, weak base. Okay, base property. It can be also used for the urgent pain if it is in a jungle. That's the we know about the kahambili, that is acid, isn't it? So that is good for our knowledge when before go to the jungle. Okay, now I think the lesson is over. But children, I have prepared 40 MCQ questions. Other class, I will do the question paper and I will send you the PDF. After that, after practicing that paper, I will give you the chance to do the online test. Okay? Okay, children. Okay, then see you. Next class will be, inshallah, we'll discuss. You give me a message, okay, to discuss the model paper. However, within this week, we have to do the online paper too. Okay, Assalamualaikum warahmatullahi wabarakatuh.